Okay. I've had several questions about what Avogadro's number means because it could be 1 mole equals 6.022 times 10 to the 23rd atoms. It could be 1 mole equals 6.022 times 10 to the 23rd molecules. It could be really anything that you are measuring and you have this many of. So, in theory, you could have 6.022 times 10 to the 23rd puppies, and then you would have a mole of puppies. Now, most likely that's not going to happen. We're going to have either atoms or molecules. You may also see it with formula units for ionic compounds. But the most common are atoms and molecules. So it all depends on what you're talking about. So if I'm talking about iron, Fe, I have one atom. So I would refer, if I had a mole of them, I would refer to it as a mole, or 6.022 times 10 to the 23rd atoms. Now, if I'm looking at water, in one water molecule, I have 3 atoms. I've got 2 hydrogen and 1 oxygen. But when I'm looking at the molecule as a whole, then it's molecules. So we either have an atom when we're looking at a singular element that's by itself, or a molecule. So if I had O2 and I was referring to a mole of O2 gas, then I would have 6.022 times 10 to the 23rd molecules of oxygen. This 2 makes it a molecule, more than one atom bonded together. Here, 3 atoms bonded together. But if we were talking about aluminum in its solid form, since I did that with the other, then I would have 6.022 times 10 to the 23rd atoms in 1 mole. So hopefully that clarifies our misunderstandings on moles and atoms and molecules. Just so we can talk about it, formula units. So NaCl, ionic compound. If we had a mole worth of NaCl, I would accept molecules, but you could also write formula units, which is the simplest form here. But most likely, I'm going to ask you for atoms or molecules, even if it is an ionic compound. So I would say molecules. Okay, let's do a practice problem going from number of atoms to grams, and then we will do one going from grams to the number of atoms. Okay, so let's say that we have 1.87 times 10 to the 24th atoms of iron. And we want to know how much does this weigh? Okay, so our first step in our conversion, we know that 6.022 times 10 to the 23rd is moles. Is a mole of atoms. So we're going to take 1.87 times 10 to the 24th atoms. We are going to multiply by 1 mole for every 6.022 times 10 to the 23rd atoms. And our atoms cancel out. And we will get something. 1.87 E24 divided by 6.022 E23. 3.10528. 3.10528. Moles of iron at this point, because that's what we started with here. This is what we're looking at. Now, I rounded this a little bit from my calculator, but I still kept more significant figures than what I want at the end. I don't want to round to significant figures till the very end. Okay, now that we have 3.10528 moles of iron, we just need to multiply by something to get rid of moles and get us grams. So that would be the molar mass of iron. So let's go to our periodic table and look that up. Iron has a molar mass of 55.845 grams per mole. So 55.845 grams per mole. And we simply just multiply that. We get 173.414 grams. Now we have 3 significant figures given to us in our problem. So we're going to round this to 3 significant figures. So the answer to this problem would be 173 grams of iron. So step 1. We went from, this is just going to show you units, atoms times moles over atoms. And then we so that gets rid of the atoms. And we're left with moles. But we want grams. So next we're going to multiply by grams over moles. So that's step 2. And then moles gets canceled out. And we end up with grams as our answer, as our unit in our answer. If you're going from atoms or molecules to grams, that is always going to be your steps. You're going to start with the atoms or molecules. You are going to divide by Avogadro's number. And then you're going to multiply by molar mass. So divide Avogadro, multiply by molar mass to get grams. Now, the process is the exact opposite when we start with grams. So let's go look at grams, and we'll say that we have 13.8 grams of sodium chloride. we want to know how many sodium chloride units we have. So how many sodium chloride molecules. So we start with 13.8 grams. This time we can't use Avogadro's number yet. We don't know how many moles we have. So we need to get to moles. So we need to multiply by something that gives us moles and gets rid of grams. Or what that really means is we're going to divide by the molar mass. So let's find the molar mass of sodium chloride. Sodium is 22.9897. Chlorine is 35.453. When we add those two together, we get 58.4427. Grams per mole. So what that means is that for every 1 mole, we have 58.4427 grams. So we got 1 mole, we have 58 point, I didn't give myself enough room. $58.4427 grams. So we'll take that 13.8 divided by 58.4427 equals 0.23612 moles of sodium chloride. Now from there, we need to make the next step, which gets us our molecules. So we know how many molecules are in a mole. So we know that we need to get rid of moles, we need to get molecules. So we're going to take times 6.022 times 10 to the 23rd, or Avogadro's number. That's how many molecules of NaCl are in a mole of NaCl. So then our moles will cancel out, just like our grams canceled out here. And we will get 1.4219 times 10 to the 23rd. I'll measure it atoms. Molecules. Units of that compound. So then we look, I gave 3 significant figures in the problem again. So we're going to round to 1.42 times 10 to the 23rd molecules. NaCl. So just like we saw here with just looking at units, we're going to look at that here. So we started with grams. So step 1, we needed to get 2 moles. So step 1, we multiplied by mole over gram, which really meant we divided by the molar mass. And then step 2, we multiplied by Avogadro's number. We multiplied by molecules over moles. Which is Avogadro's number. And you can see that the grams canceled out, the moles canceled out, and we were left with molecules. Or if it was just sodium, we would have been left with atoms.